Hi, welcome to Send to Print. Today we're going to create a fully parametric rope container. Not only can we control the size of the container, we can also choose how many times the rope wraps around and how tight the twist is. I'll also show you how to set things up in the slicer to achieve that rugged texture. Without further ado, let's dive right in. First, let's take a look at the design. These are the diameter and height of the container. We'll stack the rope using the layers parameter. So the height of each individual layer is simply height divided by layers. Now we'll input these into the parameter table, which makes it super easy to adjust everything later. Go to the Modify panel and select Change Parameters. Click the plus icon to add our first one, diameter. Let's set it to 50 millimeters. Next we have height, which is the total height of the container, set to 25 millimeters. Add another one, layers. Make sure it is set to no units, and we'll set it to 4. Finally, we have layer height, which represents the vertical thickness of each rope layer. Let's input the formula, height divided by layers. Right-click the root component in the browser and select New Component. Rename it to Rope Container. Now, let's start with the base. Go up to Create Sketch and pick the XY plane. Hit C for the circle tool. Start right from the origin, drag it out, and type in diameter. Finish the sketch. And rename it to Container. Now, hit Shortcut E for Extrude. Select that circle and pull it up by 1.5 millimeters. This is the bottom of our storage box. Let's rename this new body to Bottom. Before moving on, let's take a look at the rope's cross-section. This rope is made of 4 strands that twist along a path to create that classic texture. We'll model the rope by replicating its physical structure. Let's draw this rope cross-section first. Create a new sketch on the XZ plane. Use P to project the bottom body we just made. And hit X to turn them into construction lines. Now, draw a rectangle. Make sure to select center rectangle here. Select all 4 edges and hit X to turn them into construction lines. Use an equal constraint to make it a perfect square. Press D to dimension the side length to the layer height parameter. Now I'm grabbing the circle tool and placing it on that diagonal line, and use the tangent tool to snap it to the square's edge. Hit D for dimension, and set the circle's diameter to layer height multiplied by 0.6. This is one of our 4 strands. To finish the profile, go to Create, then Circular Pattern. Select the circle, pick the square's center as the axis, and set the quantity to 4. Here's a little trick. You can change this value to adjust the number of strands, which is a great way to experiment with different rope textures. Now, let's get back to this 4-strand rope profile. I'll draw a point right here. And apply a coincident constraint to snap it into place. We'll trim the bottom of the rope layer so we can avoid those extreme overhang angles that are hard to print. Okay, one last thing. Draw a center line across the square and hit X to make it a construction line. We'll need this as our axis in a moment. Before finishing, check for that small lock icon. It means it's fully constrained. If your lines are still blue, they're under constrained. We want this logic to be rock solid, so it won't break when you adjust parameters later. Okay, let's finish the sketch and rename it to Rope Profile. Now, Let's define the path of the rope. Go to Construct, then Plane at Angle. Select that center line we just drew and keep the angle at 0 degrees. On this new plane, create a sketch. Hit P to project the base circle. This will be our sweep path. Okay, finish sketch. And rename it to sweep path. Now for the magic. Go to Create, then Sweep. For the profile, select all those 4 small circles. For the path, select the projected circle. Here, a rope appears, but it doesn't look quite right yet. We still need to twist the section a bit. Down in the settings, find twist angle. Let's try 360 multiplied by 10 first, just to see how it looks. And there it is, just like a real rope. Now, let's change the twist angle to 360 degrees multiplied by 2. It starts to look more like rattan. If you want to stay flexible, we can make this parametric. Open the parameters table and create a new one called rope twist. Make sure it is set to no units, and just set the value to 10. Now, go back to the sweep settings and change the twist angle to 360 multiplied by rope twist. Now we have total control. Let me toggle the bottom body back on. Finally, let's rename this body to rope unit. Now that we have our first rope layer, we can simply duplicate and stack them. Go to Create, then Rectangular Pattern. Set the object type to bodies, and select our rope body. For the axis, pick the Z-axis. Set distribution to spacing, quantity to layers, and distance to layer height. To get a better look at the model, let's go to the Inspect menu and select Section Analysis. Pick the XZ plane as our reference. If you don't see anything, just click Flip. Let's take a closer look, see? The overhang angle at the bottom of the rope is actually too steep for a clean print. There's also a hollow section in the middle, which we definitely don't want in a 3D printed piece. To fix this, we really need these layers to overlap a little bit. After some testing, I'll set the distance to layer height multiplied by 0.84. This brings the angle down to about 45 degrees, making it a lot easier to print. Okay, that looks way better. One last detail, the bottom rope is sticking out a bit. Go to Modify, Split Body, select that bottom rope, and for the splitting tool, select the container's bottom surface. Finally, just remove the extra part. And there you go, a perfectly clean, fully parametric rope container. Now, it's time to see the real magic of parametric modeling. Let's open the parameter table and play around with the values. By tweaking the diameter and height, we can resize the container, while layers and rope twist let us fine-tune how thick the rope is and how it looks. You can totally use this method to create containers of other shapes. Let me quickly show you another design. I've simply changed the sweep path from a circle to a rectangle and tweaked the rope twist parameter. And just like that, it looks like a completely different design. But here's a tricky part in this rectangular version. The sweep path needs to be smooth. If it has sharp corners, the twisted rope profile will self-intersect and cause a sweep error. So you can see I've added a fillet to the sharp edges of the base body to ensure a successful sweep. You may also notice that we haven't merged all the separate bodies, but don't worry, this won't affect the print at all. Sending these independent bodies to your printer works perfectly fine, as long as you don't manually split them in the slicer. All right, this model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. After 2 hours of printing, let's check out the final results. For this one, I set the rope twist parameter to 2. It gives it a rattan-like texture. Since real rattan is quite stiff, it doesn't twist as much as a cotton strand would. You might notice the layer lines are a bit more obvious on the top curves. To fix this, you could use variable layer height to smooth it out, or use the fuzzy skin mode that I'm about to show you. Check out for this one. I've used a higher rope twist value here, so you can see the strands are much more coiled, giving it a classic rope look. I also enabled the fuzzy skin mode in the slicer to give it that cotton-like feel. Doesn't the layer lines on top look much better now? It's way less noticeable. Here's how I do it. Just to clarify, I'm using Bamboo Studio here, but you can find similar settings in most slicers. Under the Others tab, go to Special Mode and find the Fuzzy Skin option. Change it from None to Contour. I've also adjusted the point distance to 0.2 millimeters for a finer detail. The fuzzy skin adds a random displacement to the outer wall, which helps mask minor layer lines and printing artifacts. It also gives the model a soft matte finish that feels much closer to real fabric. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.